Okay, let's redo it again. We are welcoming Frank. Frank started working at NASA in astronaut training from 1966 through 1999. Frank worked with and trained all of the astronauts flying through 2005. So he had definitely tremendous impact on the training and overall success of the missions. With a specialization in cislunar navigation during Apollo, he trained astronauts in all Apollo computer operations and navigation to get back to Earth. Mr. Hughes joined Titronic Software in 2001 and continued developing training systems for NASA and other government agencies. These new systems involve development in training portability using head-ported devices. It is my pleasure. Frank, your floor. If you have, you are welcome to, I have a share screen enable. So if you have any presentation.
I do. Let's see. See if you can bring this up now.
You can bring it up, yes.
Okay, it's on my screen. If you can.
You need to share.
I need to share. Let me go back then. Hang on. Okay. Show taskbar. No. Hang on. I should have erased there. More options. Is it on the screen with the?
There's a green share.
Hang on. Okay. I see. Stop video.
And if you click on that share, it would give you a tray of different options to what you can share. You can share your screen. You can share specific files if you have open.
Okay. Let me get them all. I'm getting all kinds of good things. It's a recording and so on. Forgive me. I've done this before a lot of times, but I guess somebody else said, here, I'm making it share to you now. Okay. You can't do it for me, I guess, huh?
I did share for you.
Hang on.
But if you can email it, I will definitely share. I mean, I will show slides or whatever it is.
Okay, got that. I'm looking at the green or the thing. Oh, wait a minute, under me here. Let's see. Forgive me, all of you. Return to the meeting.
Good morning, Donna.
Good morning, everybody.
Okay. Forgive me, guys, all of you. You came to see something, and speaker view, gallery view, and all this stuff, full screen. That's great. But now there's no green. Oh, there it is. God, finally. All right, let's do that.
Perfect. Yes, it's.
You got it?
Yep.
Now, let's do this. If everybody's got a thing, it's the green screen, I'm good. All right. I'm not going to look at you. I'm looking at another screen while I'm talking to you. What I'd like to do, first of all, thanks for the introduction, and looking forward to hear from you guys. I do like you to ask questions during the pitch. That is, I'd rather talk about things right when it's trigger off in your head, and it helps everybody else, I think, to move me forward and explore some different things that maybe it's important to you and I might have missed today. But anyway, I did work with NASA for 33 years, went from 66 to 99. When I joined up, We were flying, the first flight I got involved with was Gemini 9. We had just come back from Gemini 8, and it was a big thing there because, of course, the crew had to abort and come down early, things like that. So that was a very interesting thing and involved training situations. Okay. Let's see.
Frank, right now you're showing just a black screen, at least to me. Is
It was
it
black screen. All right.
It's a black screen.
right? I
Sorry.
wasn't sure. Planning to share some
No, I thought I
content.
was sharing. Okay, I hit the button to share.
Okay.
Let me go back here.
Did you select what you wanted to share?
How about there? I'm trying to show screen 2. Let's see if it'll do it. See if you get it now. Or screen 1. Do you have something from me right now?
I still have just a message that yours has started screen sharing, Frank Hughes, and the black
Okay.
screen.
It says on here, the screen sharing is paused. I'm going to stop sharing and then see if I can go back and share it again.
Okay, that's definitely one of the ways to troubleshoot it.
Yeah. All right, let me go back. I'm
I
sorry.
saw a planet for a while, but it went away.
It was there for a moment. Okay. Have you seen my screen now?
Not yet.
Well, this is an unintended consequence, isn't it? Okay.
That's okay. We'll try again.
I'm cleaning up my screen so I can make sure that I'm not trying to show anything I want to show. Okay.
You know, Frank, you did such a great job at the presentation for ASME last year. We really enjoyed it.
Well, thank you. And I have used this one a lot, and somehow I think the dog fight has messed up my operation here. But let's see if we can get it going. Share screen. Okay, now.
Okay. We
You got it?
have it there. Yes.
Okay, good. So now I'm gonna make it bigger. And I'm gonna change so we don't have the side thing. Okay, good. Now, let's just ask a couple questions. And now you're seeing it? I just want to make sure that I don't jack
Yes.
around with it. Good. Got 2 questions on there. These people are all space geeks, and some of you I know stretch back to my generation when we joined here in the 60s. But see, I had a bunch of questions here, and I was planning to do it. But as some of you were here when I talked about it, I was in the emergency room last night to get my hand repaired after a dog fight. And I was not doing the dogging fighting, but I was trying to get them apart. Anyway, okay, what crew landed on Fra Muro? Anybody?
Apollo 14?
Yeah. And who was supposed to land there, of course?
13.
Yeah. We had a hierarchical kind of thing so that when we landed, there was a list of things, a place to go. And if one didn't get there, then the next crew was going to do that. So that's always, if you ever notice going back, Apollo 11 flight patch has no names on it. If the 11 crew didn't get it, we'd have just, Apollo 12 would have gone to the same place, Tranquility. They were just going to do that. And that's why there was no names. so that we didn't know quite who was going to actually do it. We were so damn surprised when the first crew made it and so on. It was wonderful. We won with that. How about Taurus Littrow? Who got
Apollo 17.
Yeah, you guys probably been living with this stuff. And that was Apollo 17 with Gene Cernan. Interesting on this one, we'll talk more about it another day and another time if you invite me back and I can learn how to run this system, is that Taurus Littrow was like a valley. So these guys actually had to fly down through a valley, kind of like Grand Canyon, and landed at the open end of it. And that was pretty impressive at the time, let me tell you. Still is impressive. Okay, let's talk just for a minute. Talk about training and then talk about the flight computers that we were using. In 1958, NASA was formed out of a bunch of different agencies, and that's the list of them. And it was pretty amazing because everybody had to give something at the office. It was kind of, we gave away like Marshall Space Flight Center was actually belonged to the Army at the time. It was the Arsenal, Huntsville Arsenal, and so on like that. NACA had places like Goddard and Langley doing lots of airplane things. Anyway, so training was occurring at all those places, but different ways and different times. It was interesting. Training, we had to even define it back. That was an activity leading to a skilled behavior. We're not going to go through all this stuff. But when they passed the National Space Act, it was really to find out what skills would be needed to fly in space, what knowledge would be needed to fly in space, and what attitudes would be needed. That was a really thing. It called a unique situation for sure. So the first one we were going to do is Mercury. Mercury was initiated in 58, completed in 63. During that time, the goals of Mercury were to orbit a manned spacecraft, just get it done. The second part is investigate the ability of people to function and fly in space, and then recover both of them safely. That was pretty simple, but that was the biggest thing we were trying to do, and we did. Mercury spacecraft, we could talk about the vehicles, but this is very simple. We got into the flight computer for Mercury. There was none. There was no computer at all. They had about less than 100 switches on board, and in order to figure out where to retro fire when the crew was ready to do it, they'd look out the window and point at the direction of the Earth that's going away from them instead of coming toward them, and so on. And there were some scribe marks on the window that you would tilt down 10, 20, or 30 degrees, whatever the ground told you, and that's it. So actually less than 50 switches. There was no onboard computer at all. We had rate gyros that just would stabilize. In other words, you could maneuver around and then it would hold whatever attitude you left it. We had a hydrogen peroxide RCS for rotation. We had no translation capability except for 3 solid rockets that would retrofire to come down. So there was no way to change your orbit at all, except that one thing to lower your perigee and come on home. The environmental control system was okay. It was good for about 48 hours, nothing more than that. The training was done at the Mercury procedures trainer, one at St. Louis and one at the Cape. And even those devices did not have digital. Nobody trusted digital computers, so they only had analog computers on those simulators. That's what one of them looked like. This is one at St. Louis, and it was interesting. This is how it looked like down at the Cape. One person, so you had one instructor at a time, and in order to get into it, you'd had to step into it, graduate down, and then they had a very rudimentary visual that you'd look out the window, which did nothing more than provide a little horizon idea. So this is a carpenter sitting in there. There he is. It would tilt back, so when you sat down, it was kind of restful to be in there for a long time, like you're in an easy chair, something like that. We used 2 vehicles, as you know, so the simulator had to be able to show what was going on. There was no simulation of the vehicle, just the thrust that drove you into the sky. You had Redstone, and then you had the Atlas. So 2 Redstones and 4 Atlases got through this thing until the last crew man flew, and that was in 63. And in going up there, we were interesting. his environmental control system failed along the way, but Gordo didn't tell anybody. They didn't tell anybody. So when he got home, they would bring him down right away. It was so hot. He was so much sweat. But when they got him on the aircraft carrier, he had sweat up to his knees inside his spacesuit. Just little details. And this is, if you were in the Mercury simulator, if you turned around, this is where the control center was. It's a glass wall that you see here is the only thing that separated you from the simulator. So it was all a very compact deal. Well, what did we learn? We learned that we could work and live in space. You can prepare for flights using simulators. You can see and acquire really good photographic data and a lot of other data as well. But you also need a few things. You have to save and ration your fuel. Scott Carpenter, as you know, didn't, and damn near didn't get to come home. That's a whole other story, different speech. And then you have to have a really resourceful control center with you, working with you on the ground. Gemini came along. The reason Gemini was never planned, we were going from Mercury straight to Apollo. But in going through Apollo, it realized there's a few things that we skipped over and didn't realize what had going on. We got a subject, man, and equipment to a space flight up to 2 weeks in duration, because that's what we were going to play in spending at time out there at the moon. We had to make sure we could rendezvous dark with other vehicles and maneuver the docked combination by using the target vehicle propulsion system. That target vehicle was the Gemini. That was proposed by the Air Force, and everybody said yes, that they would use that vehicle. Lockheed built it. And we would perfect methods of entering the atmosphere and landing at a pre-selected point. I mean, in Mercury, we got to the water. That was about as good as we did. We did pretty good on a couple of flights, but we were way off on others. Gemini systems were interesting. It was a two-person spacecraft. Remember, Mercury was built by McDonnell Douglas, and so Gemini just was a bigger Mercury. Two-person, we flew 10 missions from 65 and 66. Digital computer on board. This is an awesome thing. It had 4K of memory. But it was interesting because we used it to compute and display rendezvous solutions. We also did them manually in the cockpit. And we had people on the ground working on it too. We had a stabilization control system with rate gyros. It could make maneuvers by itself. You could do everything you'd want to do. We had full rotation and translation. So the RCS, we had enough jets on it so you could translate or rotate as needed. Environmental control system was pretty good. It was up to 14 days. We actually tested that on Gemini 7. And we had 2 fuel cells for electric power, which finally worked very well. A couple hundred switches and controls in there. You can see there's a bigger problem with training, because now you have 2 people to interact and the ground, and then you have all these switches that have to be dealt with. This is another picture of the thing. And this is actually, I happen to work on the movie First Man, and this is one of the panels that we used in the spacecraft simulator for that movie. And now you're down here, right here, can you see my mouse? Yes?
Yes, we can see your mouse.
Okay, thank you, Svetlana. Anyway, this is this was an octal kind of thing. You'd put in these numbers, we'll call it the digital, and this you would put in a 2-digit code and then a 5-digit code after that, and this would do that, whatever you asked it to do. So it was good for, like I say, rendezvous solutions, things like that. But you can see there's all kinds of switches and controls in here. Each guy has his own 8-ball and his own hand controller. So there was a lot of training going on. And there was a lot of training on this movie to make sure they knew what they were doing. Anyway, this is what the spacecraft simulator looked like. And when you got in here, this was actually up in St. Louis before they moved it. There was one in Houston and one in Florida. And you would move through here. There's the first flight crew, John Young on the left and Gus Grissom in the middle. And that's my first boss, Riley McCafferty, who was an engineer from McDonnell. He got hired into NASA. So that's one of my first things. Anyway, they were trying out that simulator. Later, this is Gemini 6. This is Wally Schirra and Tom Stafford. And so they wound up going up doing the first major rendezvous with Gemini 7. That's not how they planned to do. There's planned to be go up and meet with a Agena, but the Agena blew up on the way uphill. And this is, again, you can tell which one is Stafford because of the bright light over here reflecting. We always just give him a hard time on that. He went bald very young. Anyway, and here's just another picture of Wally. It's a very small spacecraft, and we had to go through a couple things. Like I say, one of the first things, not only just heavy duty, but like John Young at first flight, Gemini 3, one of his experiments is to make the first bowel movement in space. Russians never talk about that nobody did. And most people landing on the moon were still constipated. Nobody wanted to do it, but they would get there. That's a whole other lecture at a different time. Anyway, there's another pictures of them going on. We also we got into EVA, and as we did EVA, we found we had a lot of trouble. The fact is that we started using airplanes to do a simulated zero-G and all that sort of thing. The major thing we got into this, Bill Anders, by the way, who was on Apollo 8, but we realized that we had to do more than just airplane flights for 20 seconds. So this is where we went into, and the first thing in Building 5, we put a used or unused, well, I guess it's a 25-foot diameter oil tank. They assembled it inside and filled it with water, and that's the first time we went in and did anything with neutral buoyancy. Anyway, we used the Gemini Titan. Interesting things you probably don't know, but in the taking off on this thing, it was a weapon system. It didn't care about people. So even with throttling down, the guys on an uphill standing flight, it was 7 or 8 Gs going uphill. And we did a lot of work in simulators and a lot of work in centrifuges. This is what it would look like in flight. And this was a big thing because Rendezvous now was, of course, becoming more and more computerized. And so we had a lot of training to get that thing. This is one of the Agena spacecraft that was up there waiting for you. You'd come up and dock on this end of the spacecraft, and then you'd use engines to fire to get up to higher altitude. Going along, this was when we got into Gemini far enough. Gemini 10 made a first more than 450 miles altitude record, and Gemini 11 with Pete Conrad went up to more than 850 miles. So there was a lot of going on very fast. We also worked with tethers. We're talking about this, all of these things we're talking about because this is really important with the computer systems. We were pushing it to the limit of what we could do with computers. And this whole idea was we would put the heavier spacecraft, which is the Agena, at the bottom and see if we could stabilize it and stretch out that tether so you could have a stable orbital component just stay like that, because heavier one is closer to the Earth. We proved that if you did the other one, if the lighter one was closer to the Earth, it didn't work. It'd flip around. Now, talking about mission control, we had opened up on GT2, the first new mission control in Houston. And as it went through, there were a lot of growing pains in that. But this is one of the first ones. This was on Gemini 6. And it's interesting because the technology, even in the control center, was such, all of these 5 things, we couldn't in real time change the range of how far the vehicles from each other. So we started out, this one was up to 1,000 miles. This was up to 250 miles. We had to just set them up ahead of time. You couldn't just push a button and change the range and get a better picture of where you were at. See, the spacecraft is out here in mid-Pacific. And then you get down in here, I think this one, the range was 2.5 miles after 10 miles and so on. So we've come a long way to thinking about all the stuff about computers and what we had to do. It was spectacular. Well, Gemini, what did we learn? First of all, Rendezvous was really relatively easy once we'd done it right. We figured out a lot of ways to do it wrong. Docking and station keeping is easy once you understand that, physics of that. Station keeping and close-in maneuvers. Saving fuel, again, was a lifesaver. And that was John Young's mantra. He says he's dedicated to bring all the fuel home. People could live and work in space up to 14 days. like I said, we proved that with Frank Borman and Jim Lovell. Borman came back and says, he would describe that flight. He said, Jim and I became asshole buddies. It was not great. The EVA was complicated, but good planning, and so it could make it easier. By Gemini 12, we had Buzz Aldrin out there, and he did a real good job because we had handholds where they were available, and it made it moving around and control your body. It's really good. And the tethering turned out to be good. We haven't done anything else. We did a few things with this on the shuttle, but I think there's a place for that in the future when we talk about space elevators and all that stuff. Everything. Anyway, we came to Apollo now. That was what we were going to talk, but all of these set the goals. Right now, the established technology to meet other national interests in space. And one of them, it doesn't say that, but it's land on the moon. To achieve preeminence in space for the United States, to carry out a program of scientific exploration of the moon, and develop our capability to work in the lunar environment. Well, we did. 2 vehicles, command and service module, and the lunar module flew 11 flights from 68 to 72. We had the same digital computer in each machines. And it's interesting when you think about this, as you know, you probably have bought spark plugs from this company, AC, General Motors, AC Delco. They built those computers. Computers were major. We would take your breath away. 36K memory, 2K, it was erasable. It's what we like call RAM later, but we call it erasable. The CSM was autonomous, space station loss. We actually could navigate home. We tested that a few times. Firstly, I'm glad we never had to really use it, but it turned out pretty good. MIT Instrumentation Lab had built the math for this, and it was really awesome. They did all the programming in these computers. Environmental control system was good for more than 14 days, much more sophisticated. We had 3 fuel cells, and they worked pretty well as long as you had enough oxygen, as we found out in Apollo 13. The reaction control system on the service module, command module, and on the LEM. So there's lots of things. Those are all hypergolic. To get in and out of orbit around the moon, we had a 21,000-pound thrust engine on the back of the CSM. We have smaller engines on the LEM and on the ascent stage. The descent stage was throttleable. We had to throttle on it because of change in the mass and stay, because this mass is different all the time. So we had to change and make sure we could land properly. And now we got more complications with 350 switches and controls in the command module and about 200 on the LEM. So you can see there's a lot of things that the people have to learn. Size-wise, the thing was changing too. It's just if you think 3 people fit into only the command module part, lunar module will look like this. If you could look at it a different way, this is the command module control panel. And if I can look at right here, there are 2 display keyboards. This is the one to talk to the AGC or the Apollo guidance computers. Okay, so you had 8 balls, you had an entry monitoring system, and so on. And the 2 computers, this one is here, and there's another one down by the lower equipment bay, where we would use it for navigation, looking out the Sextant telescope. Lunar module, same deal. This is looking forward. This is where the 2 triangular windows and that display keyboard is right here between them. We actually had another system on board. Nobody ever gets to talk about it, but over here on the side, there's an abort guidance computer. And that was a wonderful system, much simpler than it was just able to get you back up to the command module. Size-wise, you can see where we're going on. Mercury was just like, we used to joke about it. They didn't fly it, just wore it. You had no room to do anything, even barely turn your head. Gemini a little bit bigger, but suddenly here comes this big machine. And of course, followed by a shuttle, that's 130 feet long and all that stuff like that. The vehicles, these first 2 are weapon systems. Mercury is on the Atlas and Gemini on the Titan. Then the first one that we launched, it's not a weapon system. Saturn V was built to fly on by itself. That's again another whole set of great stories out there. First I got around, this was where we were training the crews now. It was a bigger production. We had a lot of classroom stuff. This is a sad crew, but look here, the Apollo 1 crew that we lost. Gus here, Roger, and Ed White. And then the backup crew is off here. They turned out at that time, Preston Schweikert, Jim McDivitt, and it's out there. Okay, anyway, that crew. Go on. We're not going to talk about the whole thing, but when we're going to go from here to the moon. We have a great study to talk about, but you have to think about the control systems and the computers that will allow us to do all that stuff. Getting to simulators now. This is a picture taken down at the Cape, which is where I worked for the first 5 years. And we had 3 simulators. We were going to have 4. The brown ones are command module simulators, and the green ones are the lunar module simulators. And when you get into this, there's another brown one, you're on it. In other words, you're up on top of this thing, taking this picture. So this is, there in Houston, there were 2, one lunar module, one command module simulator. And then down in Houston, there was going to be 2 of each. But as the program started to slow down, we had 2 command module ones. So the one I'm standing on here is CSM2, and this one down here is CSM3. And then in the middle, this is LMS2. That's Lunar Module Simulator 2. The way it looks like a train wreck, and that's what Gus called it one time, is because all windows are simulated. That is, as you look outside, you'll see the star field, you'll see the planet below you, wherever it is, and other vehicles. So in doing that, this in the case, let's take a lunar module, this is a model shack, and you had TV cameras that would move up in a track and would look at a picture of the command module, and you'd see it in the system in here. They had the same thing over there, where you'd have a model track, and you could see the lunar module. So you could work these things together. You could tie them together in an integrated way. This is the pictures of that LMS2, that the picture was taken from up here. And now you're seeing the instructor station. This is where now you got 3 people in here, and we'd have teams of 3 or 4 instructors. Another view of that. This is Frank Borman and Bill Anders getting in during the Apollo 8 thing. So you can see they'd climb up and crawl inside all of this stuff. So this, all of it wrapped all around you to give you the sense that you're really there. And the simulation facility became more and more sophisticated too. You'd sit here in this control room and work on it. Every switch in cockpit was displayed by switch position indicator lights down here. So you see here, there was the 2 8 balls that are out there. And then there's a disk key, or that is display keyboard, and it showed up at what keystrokes they were doing. We had astronauts in and out all the time down in Florida. This is Wally Schirra. This is the Apollo 7 crew, Walt Cunningham and Don Isley. So we have, sometimes people that ask me, they say, do you ever get to meet any astronauts? I said, oh yeah, it's quite a bit of time. Actually, it was interesting because, I don't want to mention the fact that I had one of them sleeping it off on my couch last night and things like that. But there was a lot of astronauts. Now, to get to something else, not just were we doing simulation of the systems, but in Mercury, we just had such a small computer. We simulated with doing one of the host computers. And these machines for Apollo, these are DDP, Digital Data Processing Company, DDP 224. On Gemini, they had a DDP 24, much smaller. It was a pretty impressive machine by itself. It had like 200K of locations in the memory system. These are much bigger. And we had 4 of them, put them all together. 3 of them, this is the first time we had interface. There was no such a thing as data buses and things like that yet. So what we would do, we'd link these computers together so they work as a team with a shared memory. We'd have like 16K of shared memory, and this machine could write into that shared memory, and this would read it. And so that was their way to transfer data back and forth. But in this picture, there were 3 of these machines to do all of the simulation that we had to do. And then this one was a simulation of the flight computer. The flight computer now had gotten so smart and so on, it was hard to simulate it. So we interpreted. So what we did is actually took the computer system here and added the instruction. We made sure that the instruction set for this computer is the same as the flight computer. And so that way we would actually get tapes from MIT and we would load the flight computer stuff in here. So then the displays and everything that went out of it, they were actually using flight computer from MIT. And that was not the intentional, but it became a really big verification tool. We found things that were wrong with the computer software and so on like that. And the crews felt that they really was getting the best training in that regard for what's going on here. We also went through Rendezvous training, so now we were getting smart. And so we figured out how to take one machine. We had lots of script charts going on. And then we only had 2 machines for doing distance on how far you were at Rendezvous. We were getting better. Some of the crew, this is some of the instructors, you saw some, this is one of the teams that would work on Apollo 7. And this is me over here, skinny little guy over in the corner. So we had a lot of fun. We trained the hell out of it. This is the interior of this is a CMS command module simulators. And you can look at it. It looks like an old car because we're sliding in and out all the time. These things are busy 24 hours a day. The crew would train generally from 8 in the morning to 8 at night. And then the simulator engineers would get over and work on their things, putting new things in. Spacecraft had 2 hand controllers, rotational hand controllers, and 2 translation controllers as well. And then you look over here, we also had environmental system enough that we could put people under suits. This is, by the way, just to control the airs. There's a juncture where you can see the incoming air and outgoing air, just so they're testing the thing, making sure that it's ready to go when the crews got here. And the crews came all the time. I'm sorry. We would train in shirt sleeve whenever we can, but we can also practice being miserable so that we sitting in the suits go through it. And this is Apollo 10, I believe. So this would be Stafford, Young, Cernan over here. And most times we list the hatch open because after 1967, 27 July, when we lost the crew, we wanted to make sure it's easy to get in and out. This was the story, and here's John now, John Young. He was going to get down, and I'll go back one. The navigation thing is down what we call the lower equipment bay. So now he would work it. We would be, as an instructor, I'd be sitting outside talking to him as though we're the mission control, and then we'd also talk to him as instructors. And so they would go through and do platform alignments and everything like that, whatever it needed to be done. A lot of things they did. We went through the operational phases of powered descent flight, for example, things like that. We'd work on the crew where we'd put the crew and the simulator, and then they'd ready to get into LAM, so they'd actually get out of leaving one person here. They'd walk across the green simulator, get in, and then they would do undock and go all the way down to touchdown. The Lunar Module was really, really good. It had a good simulation of both the rendezvous radar and as well as the landing radar. And so this was a big thing. We did a lot of work to make sure that the crew is ready to handle this thing. This thing could land by itself. Nobody let it. But generally, we would take it over. We'd talk to it through the keyboard until about 5,000 feet, and then the crews would take it over and fly down. It's just like shuttle. Shuttle could land by itself, but nobody let it. This is what the Lunar Module simulator. It's interesting. You'd get in and out the back because the only way to do it is through the command module, where with gravity. So the flight computers were on the back wall of the LEM, and of course, then we just mocked them up. And so there was a door. You'd walk in, close the door, and you looked like you were in. Forgive me. I'm going to take a drink of my coffee here. Okay. This is what it looked inside. This is all the environmental control system. By the way, this is interesting. These 2 things are the CO2 cartridge access points, which became a big thing Apollo 13. Anyway, the guys would stand in front of these windows, and it would look like this. So here's Pete Conrad Albeen working on Apollo 12. When you did this, then they would go out the front hatch, which is down here. So we had everything down to open that hatch, but we couldn't actually go through that because it was all that visual equipment, everything to produce the stars and the visual system blocked that door. So they got to the point of lowering the pressure in the vehicle and then turn the handle and open this thing up and then stop. We had a mock-up of the LEM down the hallway, and so they would go get in that one. Another view of, it's pretty tight in there, but it's pretty good at the same time. And they spent hours and hours in. We put for Apollo flight, we put about 300 hours in these two simulators. The interface with the thing, it was MIT was pushing the edge of what could be done, and this is a DSKY, and this is out of a operations book at the time. It's a very interesting thing. First time the computer would tell you it's doing something, it's not dead. There were programs built into what was going on. There was 76 of those. And then there was a subject, verb, subject kind of thing. So we had verb 16 said monitor. And then over here, this would be the noun, what it is. Like if you'd said 1620, 20 was the gimbal angles on the platform. So you could see if it's maneuvering and so on, what's going on. If you say 6, it's like a snapshot. You'd take one shot. 16 went back once a second and do it. By the way, this whole thing was built on about 2-second cycle. Take everything down. Later, you get into this. This is up here. This is altitude stuff up here in the lab. It's a different set of nouns, but now you're talking about altitude and how to get down, range, rate, and so on. Then we had things up here that would tell you if you've done an operator error, and so on, your altitude log, if there's problems, if you don't know what it is, and so on. Program problems, gimbal lock, things like you think about. Yeah, gimbals on the platform, there were only 3 gimbals, and so there was a chance you could actually drag the platform if you got into certain locations, and they called it gimbal lock, where after, if you did that, you had to go back and reline that platform. This is what the DSKY looked like in real world, okay? And this is, you can see that the keyboard, you would type in whatever it is. So you tell it verb 16, noun 20, and enter. And that would be the communications you're doing to this thing. One of them in person, this is a DSKY right here in it. And this, in fact, is not, this is me, which I did this a lot. I put it in only because we would get in the simulator, talk through procedures. It's not like we knew more than the astronauts, but we worked it together to create the procedures to make it happen. So this is Ryan Gosling over here doing the thing. For landing on the LEM, this was a translation controller, but if there's a lever right here, you'd put it up and down, and that thing changed to become a thrust lever. So it would be controlling the thrust on the descent engine. So by going up and down, you'd be higher, it means more thrust, you'd go down, lower thrust, okay? And then this is a big button, it says stop. And the button higher up, let me go back here, up in here, right there, it says contact. And we had 5-foot-long things hanging down from each of the pad. And actually, by the time we got to Apollo 11, we took off the one in the front because they would get bent up out of the way, and we were worried about the front one would impede somebody coming down the ladder. But if that thing said contact, the next thing you do is push the button. It says you're within 5 feet of the ground, stop the engine, just plop down. This is a view of that simulator, different one. This is the one taken in Houston, but same thing. Here's the instructor console, what's going on. Here's your strip charts and so on. This is called the LNA. This is a landing and ascent, approach and landing thing. And so what it was is we put in a piece of the moon hanging upside down here. And the reason it's upside down is the magnification that we used was such that it would you could see dirt on it. So we'd work through there. Take an example. This is a picture taken by Apollo 10. And this is Hadley Rill. This is Mount Hadley right here in the west. And then if you see the arrow, you can see what's going on. Am I using this thing and not have a big picture? Hang on. Anyway, it's working. I'll just go with it. Anyway, zooming in on it. Hadley Rill is a collapsed lava tube. So lava used to fly there at some time. And then this is what it is. On Apollo 15, we landed on this plane right here next to it. And we did 3 EVAs. Apollo 15 was one of the J missions where we had enough resources to stay on the moon for 3 days and use the rover. So we did that. Well, they would make a model of the landing area. And this is that LNA. So there's a crane moving the new vehicle in to start training for 15. And then the next picture, to get the size of it, this thing, just to give you an idea, it was a big thing. It was about 20 feet across and about 40 feet long. And this is what it looked like inside the simulator. So you're coming down, and if you listen to Apollo 11 or any of the flights, if you're coming down, they're given numbers. And what the computer is doing, the flight computer is computing a number that would be 2 digits and then 2 other digits would be how far up and down the scale and how far left and right of the track. So you're coming down somewhere in here, and it's the computer saying, I'm going at 10, 40, and you wouldn't say comma, but you get the idea of the 2 things. And put you down there. You could then change it. But once it's installed, this is what it looks like. There's 2 cameras up at the top of this thing that are articulated, that as you move, as the spacecraft change directions. Bunch of lights back here are supposed to be the sun. And we found early on that we needed more lights as we get down close, because the thing itself caused a shadow. So that way the crew got to get into the thing, come all the way down here and touch down near the Hadley Rill. And get that. So that it was awesome in terms of the crews really, really loved that kind of stuff. And they would come back at night and do other landings and so on. They'd also do other things. I mean, once we get on the ground, this is down where the CMS-3 was going to be. So we put a mocked up LEM, and the crews would go out. This is Apollo 14. So this is Al Shepard. Oh, it is. Flag, I'm having trouble this morning. Anyway, and so he's planting the flag. You see, we take out some pieces of the floor and put some sand in there, so they'd come over and plant the flag. At Mitchell. Apollo 12, we proved that we could do a pinpoint landing. So this is a, go ahead.
Frank, you had a flag story. Do you want to mention the real planting, not just in the simulation?
Oh, it's true. Okay, thanks to remind me, but that's good. Another drink of my coffee. Sorry about that. Okay. The way it works out for Apollo 11, the State Department got involved. Somewhere about 2 months before we launched, somebody in the State Department realized we were going to the moon and we might just land. And so the question was, should we put a flag or not? So we had actually procedures where the crew actually went through and they would put the flag up. And then our flights went through with the procedures and they didn't put the flag up. Then they went out and bought a flag, and it was a cheap, miserable little thing. We modified it. So the thing is, you would hammer the bottom part into the ground and then stiffen the other thing on top of it. And it had we had to modify it to put, the flag would just hang down limply. So we had a brass rod that we soldered in across the top, and so to make the flag stand up. Now that's the story before we left the ground. We raced up there because we didn't do much of this. And it was actually, there was a big thing with the First Man movie because we didn't show them putting the flag up. If you go back to the real flight, it was job for Buzz to put the flag up. And then we were going to talk to the president and the salute and everything. But when he got out the thing and started hammering it into the ground, after about 6 inches, it wouldn't go. It was like a hard pan underneath there. First of all, they landed and they put it too close to the LEM. So when they took off, that flag is down. It didn't stay up. It was barely, like, it would stay up at the time. They beat the hell out of the top of the thing, trying to get it go further. And of course, the hammer, the geology hammer that they had, bent the top of the thing and so on. So now Neil came over trying to help them to get the upper part of it into the now beat up lower part, the top of the lower part. They managed to work. And then they said they gave him a call. And so President Nixon wants to talk to them and salute them and, what a good job they're doing. Both of them are trying to scoop subtly. If you watch, they're scooping sand up around the bottom of the damn thing because it won't stand up by itself. So they got enough so that it's there. They knew it was going to fall down in real time when he was talking to them from the ground, but they managed to make it without having to hold it on and got it done. Now, after that, we sent real good flags up there, and we knew that it had a pointed end and so on. It's going to go through more of the soil, and we put it further out so that those flags are standing up still. Now, I don't know about today, but when they left, they were, and so on. But yeah, it's kind of you got a double whammy on that story. It was kind of interesting because we would train the hell out of anything we were going to do. But even up to the last week, when they launched, the flight plan does not show putting up a flag. And we had to pencil it in. John O'Neill, great guy that ran the flight planning business, flight procedures. He and I were doing pen and inks in the cockpit in the command module. It's a Lunar Module book, and they had to carry it across to make sure it had in the flight plan that they were going to put up a flag. Okay.
So Frank, are you saying that the flag that was planted for Apollo 11 is now not there anymore, or whatever happened to it?
Laid down. When the blast came, the blast from gases from the launch from the ascent stage and from the descent stage, they put it straight out just to the right, about 25 feet. Okay. And so, like any piece of cloth, it's going to act like a sail. So when they blasted off there, it blew over, fell over. It was hardly ready to stand up by itself anyway.
So it's still there. It's just laying on the ground somewhere.
That's right. That's right. Now it might have flown some distance, but it's there. Now everything else, if you notice, the flags are about 56. In fact, some of them are 70 feet away. Okay, and they pretty much are stay there, standing up. Okay. Any other question? Apollo 12. We did the first pinpoint land. I mean, we came down and Apollo 11. There's a whole story about Neil. We took pictures of the Apollo 11 site, and it looked great. It looked just like the top of one of your gray desks you used to have at NASA. It was great. But the problem was when we landed there is he's coming down, he's looking out the window in Buzzard, being shocked because there was a boulder field there. And it turns out as they get closer, some of the boulders about the size of Volkswagens. Turns out, even though we took some good pictures on the thing before, the pixel limit was such, those boulders were smaller than the pixel size that we had. So what made it look like a real nice, smooth plane turned out to not be that way. So that's why he had to stay up. He kind of stopped, descended about 500 feet and flew on beyond the boulder field, and then to put him in across a crater. He had to make it across, and then he landed just past that. And that worked out well after that. While we're there, the command module, when they were flying around, they took pictures of every other landing site that we could get. And so we knew pretty much better things about where we were going to go for 12, 13, 14, so on. And then on 15, 16, 17, we had a module in the command module, in the lunar module. Geez, I'll get it. On the service module, back behind the command module. And we put in there some of the best spy cameras that we've had. And so during that time when they're on the ground for the 3 days, Al Warden was the first one. he was up and taking pictures of various strips of pictures across lunar landscape. So in those areas, we knew a lot about those future landing sites and a lot of other stuff about the moon, but only covering those areas. Well, I was concerned about that. Those cameras were some of the hyper secret things that we had, but of course, we worried about somebody capturing, but they were in the service module and all that equipment burned up on the way into the atmosphere. So on a slope on Apollo 12, they could have landed right beside this thing, but they didn't want to. They didn't want to sandblast it from the gases and the sand that they ride up. On top of that, it's on a crater. So as we came in from the west, they flew across it. He was sitting out here on about a 25-degree angle. And so we built this. This is one of the mock-up of the surveyor. And the lunar module landed about 100 yards away. The crew, when they get out, Al Shepard and, Pete Conrad and Al Bean, they walked around the crater to get to it. So there's some good pictures on this stuff. But one of the sad things about that flight, because one thing we didn't do is they took a really good color camera, the first one, but when we got there and getting it out of the mesa, out of the place where it was stored, Al happened to put it over his shoulder because it's heavy and it pointed at the sun. And so it killed the Vidicon. So you don't have any real-time videos of Apollo 12, except the landing, which was my camera, a different camera inside. Now another picture here. So that's the surveyor. It's an interesting thing that we did this. They got there and took pictures of it and so on. And up in here, there's a camera and there was a cable coming down this way. And the crew, what they would do it is they had, JPL had doctored up that. So they put some bacteria inside that cable. And so we were to go up and cut a 12-foot seconds, a 12-inch chunk of this thing, a 12-foot inch, and bring it home. And when we got it back and the guys tested it, those bacteria in there were just as happy as clams still. They were ready to go back to life and so on. So that leads you to think about how many different kinds of bacteria and things are flying around out there in space. And maybe that's where life came from down here on Earth, from some rock or something still flying by. Then they would go outside. This is the building where all the simulators are. This is the MSO down at Cape, if you know the area. So they had an electric version. They drive around. This is not, this is the penultimate moment of us. Here's humans, got these fancy suits on, these fancy driving vehicles, and they're going around. And it was pretty impressive that we are pushing our civilization to the point that we could do that. Interesting thing is that Apollo 16, John Young and Charlie Duke were driving one of these out there, and they had to stop, call Houston. This is Apollo 16. One of the simulator instructors come up online, and they said, would you call the Florida Parks and Wildlife guys? Turns out with this guy driving along in one of these dark areas, dirt trails that they were driving on through the badlands of out here in Florida, there was a big alligator sleeping, laying across the walkway. So he's about a 12 or 14 foot gator, and they're sitting there, these guys with their suits percolated and steam coming out of them, keeping them cool and everything. And they couldn't get by this thing that's genetically probably 20 million, 30 million years old. And so I wish we had pictures of that. I think there's pictures. It's old Bubba comes up in his, white Florida Parks and Wildlife truck and throws a lasso around the thing's tail and drag him out of the way. So our advanced explorers could go on down the road and do their simulation that day. Anyway, so what did we learn about this thing? Guidance and navigation between the planets is understood and operationally easy as long as we have enough navigation sense. Landing on the moon was straight, and we did it a lot. Let's face it, it really turned out good. The system that we designed, actually much of what we're doing is going back using the same software algorithms, not the software, but the algorithms. Lunar surface EVA was great, but the balance of the suits was critical. EVA gloves were a continuing problem. And this, if you think about, and I've got my hand up here, you know, the space suits are a problem because it's a balloon. And the biggest problem we still have after all these years is how to make a handle. That's why, like, if you see they're working with a tool up there and they've got like a hammer, that the hammer, the handle on the hammer is big. So they only have to go down about this far, because making that move, it takes, when they come back in, everybody, the fingers are bleeding inside, you know, inside the gloves, because they're so hard to make a fist. So that's a big thing. Gloves are a continuing problem. We'll work on it, but so on. Lunar dust was a big problem, and we know it's going to be waiting there for us. That means gradually on the third EVA of some of those flights, it was difficult to put the suits together because they would, the dust had screwed up the threads of the locks that would on the suit. So
Question.
Go ahead.
Okay, Frank, could you elaborate a little bit on this lunar dust? It's not only the suit, it has such a multifarious, whatever, effects on the systems, operations, and everything. Could you spend a little bit of a few seconds to say how deeper this problem can be?
You bet. Kumar, thanks for that. Let's face it. What happens is the big problem with this is if you have some dirt, you go to the beach or whatever it is, and if you look closely at the sand there, and it goes down to the same thing if you change the scale until you talk about dust. Every of that has been ground up and eroded through rain and other water features, so that the thing is pretty much like a little ball. Okay, it might be irregular and might cause trouble, but those kind of things give us minimal trouble in what's going on in a machine down here on the Earth. But on the moon, there's no erosion, there's no things going on, there's no water or any action except micrometeorites coming in. So every time you see something that looks like dirt, if you look at the pieces under magnification, it much looks like pollen. They're irregular, they're terrible, sharp edges and so on, and they cling together. Plus, they're very hard minerals, so they will start scoring the inside of any kind of a device that you put two devices together, or anything that has to rotate at all. And so it's going to be a problem we have to face. There's a lot of people that are working on it, but it's amazing. If you just do a Google search on what lunar dirt looks like compared to Earth dirt, it's just amazing. It really looks like, you know, that's why the crew, they talked about, they get back in the thing and try to go to sleep, but they had a funny smell all the time and taste to their food. And that was because this dust came in with them. And of course, even though it's now 1/6 G, it still was floating around inside the vehicle or being blown around by the ventilation system. And it got like pollen. They'd start sneezing and things like get into it. So it's.
Is there any toxic material that, I read about Harrison Schmidt, Dr. Schmidt on Apollo 17, he had a problem because of toxicity.
He had a problem at the time. He's talked about it a lot since. At the time, we considered it like hay fever. I mean, we're talking about years and years ago. We've had things to think about 50 years. In fact, for him, it's 48 years, I guess, 49. So I think that I don't think anybody proved toxicity because we brought all the stuff home and nobody found anything. But there's certainly a certain problem with this kind of stuff because if you inhale this stuff, like again, even though you inhale a lot of dust, unless it's something like talc or asbestos and stuff like that, if you look at the molecule of asbestos, you could understand why it would cause trouble when you get it in your lungs. Most other things, like if you go to the beach or you have a sandy place in the desert, you're going to have some problem. But most of those things are not so aggressively irritating the tissues. What's going on? Where the molecules of some of those other things that cause. My grandfather died. He was a miner up in Montana, and it called silicosis. And so that's where you get different kinds of combinations that are very jagged, the way the molecule fits together, and it causes a lot of irritation on the tissues that it lands into, inside your lungs, inside your eyes, just everywhere. It's just really tough on you.
Thank you, Frank.
Sure. Kumar, I think that there's a lot to be said about that. Just realize that the gloves are still a problem, that the dust is a problem, and we're going to go back into it. And so it's like, on your camera, you have a great oil phobic thing they called some glass where there's no fingerprints on the lenses for your camera. It's really amazing. You look at the front of the camera and there's fingerprints all over it. But if you look on the thing where the camera is, there's no fingerprints. It's just amazing because they've got this oil phobic stuff. Well, we try to come up with something that's lunar dirt phobic stuff, but we're not there now. So it's going to be interesting. Okay. Anyway, at the time I wrote this, it says, we'll go back to the moon, land anywhere with it. Now we're talking about navigation capabilities and control. Otherwise, there's a lot of problems like we just talked about. And we could go anywhere else if we decide to. I just want one thing to think about this, if we decide to, because these vehicles, remember we talked about Mercury and Gemini and so on, using Redstone and using Atlas. But if you go up here, you probably pay attention, but when we launched Skylab and ASTP, we used a rocket like this. It's called the S1B, okay? It was made to just get into orbit. We weren't doing the big job of lifting everything off to the moon. This is one of those S1Bs. And if you look at these, the way it's structured of it, it's a bunch of long tanks, okay? And then we launched on Skylab with the first one. We took one of these second stages. It would have been a third stage on a Saturn V, but the second stage on here, and we put living quarters in it. That became Skylab, okay? But this is at Michoud, Louisiana, and they were building 1Bs. And you can see they'd have a long central oxygen tank and then 8 other tanks around the periphery. And this hold it together. If you look at these, here's a bunch of those tanks. Do you see what that is? Those are redstones. So we could cold roll the steel to make these things by the yard, and then we put engines on here, J2s, and this is where they're going. That's not J2s. I'd say that this is a kerosene oxygen engine. I've lost the name of it, but you get the idea. They were cranking these out, and we could have started sending things up into orbit in a big way. We thought we were going to go building a space station real soon. The first one we built, Skylab, was just a placeholder, but so you can see we built up on pieces. So it's everything. Everybody says, why did they pick such a strange number, like 33 feet diameter in the Saturn V? Okay, this one, 33 feet. It's not a train. I mean, that's 10 meters. All of our German engineers over in Huntsville, they picked 10 meters. They put 7 meters up here. So when we convert it into our English language, it's got real strange numbers, but they were round numbers for them. And this is Michoud looking at it. This is just part of the NASA Navy. I was just talking about the fact we could be cranking those things out today still. Now we're doing the new one. The new one is a central core vehicle that they're trying to get on the new SLS. And I don't know what the hell has happened to that, but I guess they had a problem with the 8-minute fire. It shut down after 67 seconds, so we'll see. But anyway, in order to get us off the ground, we need lots of rockets. Separately, my job always to make sure you can get home so that the navigation control devices, so it's really good. I'll stop there. Any questions?
Thank you.
My pleasure, Guy. It's
Frank?
fun. Yeah.
did somebody else? I wanted to ask you a different question.
Sure, go ahead.
You were at Johnson Space Center and you were inspiring a lot of people. One of my colleagues worked with you, Jerry Pells,
Oh, yeah.
and Jerry would tell me so many great things about you. And you may not recall, I went and asked you to give me a job. He, made me so, how do I say, impressed about your capability to inspire. I was wondering, how did you inspire people? Is there something that you can share with us?
That's a good question. I don't think I did anything special. I've always been impressed with the human element. In other words, my degree is in physics. So when I came in and got into the business, I gravitated to it with luck as it was had. The first job they offered me was in flight simulation. And I said, I'll take it. What is it? So it was out of graduate school. I wanted to make sure, I thought I knew, but I wanted to make sure they told me what this meant. And I was supposed to work at JSC, but just 2 weeks before I got in the car and drove down, I was living in Montana, grew up in Montana, Butte, Montana. Anyway, when I was about ready to go, this guy calls it and says, I'm sorry about that job in Houston. And I said, oh crap, they read the resume, it's all gone. So you can fly away. He says, no. He says, wait, we need to send you to Florida because we have an opening down there. So I said, well, don't throw me in the briar patch. I mean, they fly rockets from down there. And it turned about a really, really good thing because the crew is down there. They're dedicated to train. They're dedicated to go out and drinking and raising hell too. But the fact is that you had their fingerprints on the people right there at the end of it. And I've never been impressed by astronauts. I mean, I love guys individually, but you're trying to keep them alive. So it was just like doing anything. And then all the people that work for it, it was the same thing. I think you just know that the people came in to do a really good job. Somebody always says, that they're ordinary people doing some extraordinary things, but a lot of them were, and a lot of you people did that. You just worked above yourself to make sure it was all working great. I just like people. It's interesting, during the time I was there running the training business, we wound up where it was an all-male operation. When I had retired, it was 52% women. I mean, so we had hired some of the best engineers that I could find, and a lot of those were women, let me tell you. That went from, I remember one time we were doing lessons in astronauts for the start of the shuttle, 78, 79, 80. And so we'd have to suit up and go in and talk to John Young and all those guys. And they were a tough audience. You'd have to go in and they guidance, control, navigation, things like that for the shuttle. And I tell these women, I said, you go in there, just a branch chief or section head branch chief through that time. And I said, okay, you're going to go in and it's going to be tough. Okay. If you need to cry, you come back here and cry in my office, not in there. And they went in and did a hell of a job every day.
I have a question related to a Gemini mission that occurred a little bit before you came in, but it has to do with a Gemini 4 station keeping failure. And I've sort of been researching why did the station keeping failure occur and why was the crew not prepared for that?
That's a really good question. I think nobody understood the orbital dynamics that comes into play when you're trying to do station keeping, okay? If you're within 50 feet, you can just press forward and it goes straight into the vehicle. Well, it doesn't, but the permutations and combinations are small, it's not just there. If you go to Apollo 16, we had the same kind of problem. Ken Mattingly, they had a Cirrus control system, SES problem on the command module. And they didn't want to start the descent to the moon until they knew that it was working right. So during that time, he tried to do a straight line rendezvous back to the LEM. and burned a ton of fuel, okay? Because he should have thought about that it was the wrong thing. If you're ahead of the vehicle or behind it, if you're in exactly the same orbit, the problem is always there that if you thrust toward it, if you're behind it and thrust toward it, that adding energy is going to make you go up, but not straight. It'll go straight toward you a little bit, but it's going to go up more. And the impact of that, of course, is you're going to miss the thing, and then you wind up firing down to try to get back on the thing, and so on. So what we don't have, we did have, but we need now, is some really good close-in navigation aids, things, because people get excited. Excited mean there's something wrong, and they're trying to follow a timeline and so on. So you could get through it. When we did it on, I talked about that on 4. That was with McDivitt and White. The simulator didn't do a good job showing what it was. They were trying to rendezvous in there, and it just didn't work. What the hell were they rendezvous with? It was just, they were trying to maneuver. I think it was a Phantom. They're just trying to get close. But
It was the second stage of the Titan.
that was it. Thank you. I couldn't put together that. It was an easy thing to do, but the fact is they were trying to do what we called later a straight line rendezvous. Just doesn't work. And even the people on the ground didn't get a handle on that. Everybody got pretty smart. I mean, we would have never got to the moon where we did if we didn't do the Gemini programs, because we went out there and failed different ways. You know, we had like Gemini 5, we spent the whole time drifting in space because one of the fuel cells fails. They had a problem that was fixable, and it was fixed right away. Didn't have any problems the rest of the time. But there was those same fuel cells that carried us on the moon on Apollo. We had problems with the rendezvous navigation kind of things where the equations were okay. By the way, we trained them actually to do that by hand. It was so simple. And just to give you a gouge on this thing, that at the time, if you are close to the Earth and say you're 150 miles up and you fire at the perigee, you know, we're talking about a Kalman, one of these kind of orbital transfers. If you fire plus 2 feet where you are, it doesn't do anything to your orbit there, but opposite side of the orbit, you'll be up to not 1 foot a second would give you, I'm sorry, I'll come back around. 2 feet a second will give you plus 1 mile on the other side of the orbit. It doesn't do anything there. And that's the problem. If you do, let's say you're out 50 feet and you try to go push straight in, then you'll actually drift upward because you're going to a higher apogee on the other side. But of course, it takes 45 minutes to get there. But we used to talk about that. And gradually, we have numographs where we could fly and actually they can do a rendezvous manually as long as they were in plane, okay? You'd also, if you burn up or down toward the Earth or away, you can rotate with 100 feet per second energy. You could rotate the line of apsides by 1 degree. But then the tough one is, if you're out of plane, you're screwed. If you're out of plane, to change the orbital angle by 1 degree, you took 1,000 feet a second of energy, okay? And that's why when we are doing rendezvous, the plane, you insert into the rendezvous plane to start the rendezvous during the main stage of the rockets. If they inject you, say, in and you're 1 degree out of line, then you're not going to do a rendezvous. You don't have enough fuel, you know.
Thank you.
Sure.
Hey,
Sure.
Frank,
If you ever want to talk about, by the way, you can get to me through any of you, I just say that. And if anybody's interested, I've got a bunch of things posted on, you know, on the web, and so you could get some of these other things like this. Also, maybe sometime you'll invite me back, Svetlana. We've been I'm talking about some things like that. But let's go by by everybody, whoever went to the moon was constipated when they landed.
That would be a really nice topic for one of our future discussions, I think.
Well, it's true. Let's go
Yeah.
back. That's why Gemini 7, which is the first one, say that it was all kinds of things. You get into problems of taking humans into space. If it's just computers, no problem. But if you take people, then you want to make sure that your crew, nobody has long hair, because of course, as you know, when you comb or brush your hair, there's all kinds of hair in your sink in the morning. Well, that hair is flying around in the spacecraft. You don't want to fly with anybody with dick. That's even worse. And so on. And the same thing when you get through the things about voiding urine or
Well,
feces.
human element definitely adds another level degree of challenges to space exploration, and there's so many issues that need to be addressed in order for humans to stay alive and well and return back to Earth. So it's not just a one-way ticket. It has to be actually two ways.
That's exactly right. And let's touch this one. And men, I say mostly men. I saw Julie Reed is there. I don't know who else, maybe. But let's go through just one thing. If you go to urinate, and they're always worried about aiming, okay? And yet the human system, it's not a pipe. It's like one of those flat hoses that rolls itself up by itself, okay? And so when you try to send fluid through the hose, it turns into a very turbulent thing. And you may, with luck, you get a straight stream. Otherwise, it could be like a lawn sprinkler, and it could be damn near 180 degrees side to side, okay? And it doesn't work. But, and of course, the females are always complaining about this. But the fact is, having been, when we were developing the shuttle toilet, we had some volunteers and some people, Navy nurse went up and tested that toilet, and it was great. But the fact is that they had cameras underneath so they could see how it behaved. And in doing that, what I came to the knowledge that the human female urethra behaves just the same way. The distance is, the difference is the distance. If you sit down, you don't get into all the problems. But it goes
right, and
everywhere.
The trainer,
Yep.
the training is addressing that as well. And in Building 5, we still have right now it's a historical the toilet training facility where astronauts are in comfort of their own, by themselves, training how to correctly place themselves and attach to the toilet, so then there's no accident in.
Oh, it's true. It's true. The fact, when we put that together, because we were having trouble on the shuttle toilet, and so we put a toilet together. Those of you who don't know, we put together, and we put a camera at the bottom looking up, so that, and then we had a simple camera, and then a 6-inch monitor right beside, so only the guy could see it. And there was a lot of jokes about that. Make sure that then this wire goes from this camera to this TV, because we didn't want to go out on Space Center Houston, in the live show of what's going on over there. But anyway, so that Hank Hartsfield's and Paul White's were getting down here and tested it. And so I stepped outside when they were in there, and they were the first one to fly it on 8, I think. And this training was going on. And pretty soon they started laughing. And I stepped back and said, "What the hell's wrong with you guys?" Which I might say which one was doing. But anyway, males, they have no care about almost anything. They'll do whatever. So anyway, she says, "You have to come around and look." So one of them had decided to be the first. So I dropped trowel, sat down there, and then you can have this view that you normally get of the nether ends of your body. And so they were pretty embarrassed about all that. So they start laughing. Well, as soon as you start laughing, your anus starts pulsing. And then they start laughing about that. And then they got worse. So they pretty soon they're out of control because of this view that they were getting. So it's just the kind of world that we live in out there. And it's fun, really fun. Okay, it's back to you, Svetlana.
Well, thank you, Frank. It was definitely an experience and always enlightening. Having shared information from the past, from previous programs, it definitely helps us to prepare for our future endeavors, future exploration. And of course, right now, as we are working on Gateway, working toward the going back to the moon, and this time going back to the moon with a first woman and the next man, and to stay there. It's even more so important because we want to learn on our previous experience and not necessarily reinventing the wheel. So yeah, I would like to express appreciation to Frank and also Gary Johnson that has been presenting before, that we learn and through this engagement, we enrich our knowledge and can use that experience and expertise for our future missions. So thank you very much. Thank you for attending. Thank you, Frank. Thank you, everyone. This session was recorded. I will post it on the SpaceGeekSpeak channel. And I will also update our announcement on the Engage platform on AAA, those that have joined us through that platform. And one more thing that before we end today's session, Charles Mudd, and he just appeared on the camera, will be our presenter next week. And he will be presenting a very important, a different but equally important topic on the space law. And this is in preparation for congressional visit days. We had a change of administration. We had a change in congressional representation in some districts. And this is AAA advocacy is a very important part that we are participating. So I encourage everyone that can. This year, CVD, Congressional Visit Days, will be virtual. So there's no need to take time from your work, no need to fly anywhere, no need to stay anywhere. You can do it from the comfort of your home, but still make impact on and make sure that your representatives know how important it is for you and for our nation, space exploration. We do not want to be behind other nations. And with that, thank you so much to join. I'm looking forward to next week. Charles will be our presenter, and Frank, you will be back. I hope soon.
You gotta take care.
Okay, thank you very much, everyone.
Thanks, Frank. That was really great today.
Yes, have a great day, and we'll see you next time.
Yep.
Thank you, everyone. That was amazing, Frank. That was fantastic.
Excellent. I see a lot of names there, a lot of friends. So there you go. Take care again.
Bye, guys.